everybody. Okay, so this is the review packet. This is review for sections 1.3 through 1.6. Here's number 1. I will be doing some explaining at the end of the packet about the graphs, so just keep a heads up for that. Here's number 1. They're asking you to find the rate of change, which is just slope. So this and this are the same thing. I found these two values on top down here by substituting the x values into the formula. This one, you have to interpret the table a little bit. On the table, there are values for x, but they don't fill them all in. They just give you the first one. They tell you that you should consider April to be the x value of 1, and then all the other months therefore would be 2, 3, 4 following that. So I filled that in so that I knew what all my x values were for May through December. Now, they want us to find the average rate of change, which is the same as slope, from June to September. So we needed to find an x value here to pair with a y value to make our ordered pair, and the same thing here. So that's why April being number 1 is really important, because then that gives you these two numbers, 3 for June and 6 for September. Once you have those numbers, you just use slope to find your answer. Difference quotient question. Remember, you need to pause these so you can write them down. Okay, there's an order of transformations. So as we move the graphs around, we're going to apply the horizontal shift, the narrowing and widening, reflection, and vertical shift in that order. So, for example, number 14, it tells us that as we go from x squared to the quantity x minus 6 squared plus 2, that is telling us that we're moving right 6 and up 2. According to the order of transformations, we would move the horizontal first, and then we would do our vertical. So that's what I did. I took my regular graph, centered at the origin, which is just x squared, and I moved it right 6 first and then up 2. Now, you may think that that would give me the same answer if I went up 2 and right 6, but if there's something in between, like a reflection, as we have with number 15, you're going to see that it makes a difference. So here I have a reflection over the x-axis, and that occurs, according to the order of operations, second. I have a horizontal shift, I have a reflection, and then I have a vertical shift. So I would do them in that order. And so, first I took my regular parabola, I moved it left 4 to get this one. And then I flipped it over the x-axis, which made it down here. And then finally I moved this one up 3, so that put it right there. And here's this one. Again, according to the order of transformations, I did my horizontal shift first, then I widened it, then I reflected it, and then I did the vertical. So you can see numbers 1, 2, 3, and 4 is the order in which I changed it, starting from the original function. That's the f of x equals x squared, that's centered right here at the origin. So first I moved it left, then I reflected it up, then I widened it, and then I flipped it upside down, and then I dropped it down 1. Number 17, I think that's pretty self-explanatory. Horizontal goes first and then down, so I went over first and then down to give me this graph right here as my final position. And then finally number 18, this was third. These are the steps, number 1, 2, and 3. So I took my original graph, which is the square root of x, which looks like that. I moved it left 2, which put me here. I reflected it over the x-axis. Over the y-axis, which put me over here, because this goes this way when you reflect it over the y-axis, and then I moved the 2 down. So this is my final graph right there.